Hey, good morning, Calculus 1. Uh, so I'm in section 5.4. I want to do some definite integrals. And I don't think I titled anything section 5.4, but we've hit this idea before. This is the fundamental theorem of calculus. An integral from a to b. This was kind of new, a definite integral of this function. You find its antiderivative, which we denote capital F of x. We evaluate it from a to b. That's the way we talk, which means we plug in the b, big capital F of b minus big capital F of a. Anyway, we evaluate that. We get a number here. We do get a number. And so far you've learned that that number is the area under the curve. I think I need to refine that definition a little bit, but you can just do definite integrals and not worry about area, technically. And just practice doing these definite integrals. Now, so let's try a couple here. So I've got a few here on the board. So I want to do this integral, 4 plus cosine x. It's easy to do. You integrate the 4. Anybody know how to integrate a 4? Good job. Anybody know how to integrate a cosine x? Cosine x. I think you get negative sine x. Is that right? Hang on. What's the derivative of sine? The derivative of sine is cosine. No, hang on. The derivative of sine is cosine. The integral of cosine then would be positive sine. Sorry about that. The integral of cosine is a positive sine x. The derivative of sine is cosine. The integral of cosine is back to sine. Yeah, thank you. Evaluate that from 0 to pi over 2. And here we go. We plug in a pi over 2. That's 4 times pi over 2 plus the sine of pi over 2. You plug in your zeros, minus plugging in 0 there is a 0. Plugging in the 0 there, the sine of 0 is a 0. So it turns out plugging in a 0 is just a bunch of zeros. That's okay. And we're done. That's a 4 pi, let's see, that's a 2 pi, and that's a 1. 2 pi plus 1 is the answer. That's 6.28 plus about 7.28 it's a number. Like I said, it's a number. Okay, let's try this one. Here's an integral, x squared minus 9 from 0 to 3. Okay, I'm going to do the antiderivative. X squared, that's 1/3 x cubed, right, you guys? Plus, minus a 9x. Okay, thank you. And from 0 to 3, I plug in my 3, I plug in my 0, and I subtract. Here we go. Plugging in a 3 is 27 over 3. That's a 9. 27, yeah, wait a minute, 27 over 3, yes, that's a 9, minus 3 times 9, that's 27, subtracting, and then plug in the zeros, but those are both zeros again. 9 minus 27 is negative 18. This answer is negative 18. So that's the answer, it's okay. Let's try this one. This is a famous problem, I like this problem. The antiderivative of sine x. I think that one's negative cosine x. Let me just check. What's the derivative of cosine? Negative sine? So what's the integral of sine? Negative cosine. Okay, I got it. From 0 to 2 pi, let's see what happens. You plug in a 2 pi. You get negative the cosine of 2 pi minus, you plug in a 0, be careful, all these zeros have been zeros, but not on a cosine. When you plug in a 0 to cosine, you have negative the cosine of 0. The cosine of 0 is not 0, so let's see what we got here. That's cosine of 2 pi, that's a 1. Oh, wait, it's a negative 1. Hold on, moving over here. That's a negative 1, and this is plus, minus a negative, that's plus a 1. So that ends up being 0. Cool. That integral is 0. So I don't want to confuse you here. I want to point out, when you do an integral, these definite integrals, the answer is a number. The answer is a number. And so this one had a number, 7.28, 2 pi plus 1, approximately 7.28. That when we did this integral, it had a number. It's negative 18. This one had a number. It was 0. So the number can be positive, can be negative, it could be 0. Now that could bother you a little bit because you've been trained to say that this is the area under the curve. And then you may say, well, how can the area be 0? Or how can the area be negative? Well, let me try to explain it. A definite integral treats area under the x-axis as negative. And that's okay. I mean, these questions weren't asking for area. These questions were asking, please do the integral, and that's the answer. Please do the integral, that is the answer. Please do the integral, that's the answer. And to explain a negative answer or a 0 answer, I have to say that the integral treats area under the x-axis as a negative quantity. So if I'm going to define this as area under the curve, I think I will need to just modify my definition. I think I want to call it the net area. And I'm not going to say under the curve. I'm going to say the net area between the function f of x and the x-axis. But I'm using the word net area, so you got to keep in mind area below the x-axis is treated as a negative number, area above the x-axis is treated as a positive number, and it will add that all up, and we could get a net result that's negative. We could get a net result that's positive. I mean, this is just one interpretation of an integral. And again, you should just do the integral. So to illustrate this, I don't know, let me just, can I draw a quick picture here? This is this function 4 plus cosine x. It looks like this, I think. Oh, and I'm going from 0 to pi over 2, 0 to pi over 2. I think I'm only doing, even less than that. Am I doing, hang on, that's 2 pi, that's pi. Yeah, I'm just going to here, pi over 2. So we found that area, I guess. I think I did that right. I tried to graph that function from 0 to pi over 2 and illustrate the area for you. Check this one out. I'll try to illustrate this for you. Again, you don't have to do this. You don't have to interpret these as area. I'm just trying to help you. This answer came out negative 18. Here's why. This graph, x squared minus 9, is a parabola that's pushed down 9. And it sits here. And it crosses at 3, and what were we doing? We were integrating from 0 to 3. So what we were doing was we were finding this area, the net area between the function and the x-axis. Because that area is below the x-axis, it came out as negative 18. You know, if the question said find the area, and you were determined to make the area a positive answer, you could do this work and realize this picture and then just change the answer to a positive 18. But that wasn't the question. The question was do the integral. The answer is negative 18. I like this last one. If I'm integrating this sine function from 0 to 2 pi, a sine function looks like this from 0 to 2 pi, and now you can see why the answer came out 0. You can definitely see why the answer came out 0. It accumulated some positive area, and then it accumulated some negative area, and the net result, the net area, was 0. All right, there's a lot more to say in 5.4. There's some stuff about the average value of a function, the mean value theorem for integrals, the accumulation of area under a curve, the second fundamental theorem of calculus. So there's several more ideas in 5.4, but you start by doing some definite integrals and just getting these numeric answers. Antiderivative and evaluate. So good luck.